Hello friends, welcome to chemistry classes by Vijay Kumar Sethi, class 11th chemistry. We were discussing unit 6 thermodynamics, and in this video we will discuss about lattice enthalpy, Born-Haber cycle, enthalpy of solution and enthalpy of dilution. First come to lattice enthalpy. The lattice enthalpy of an ionic compound is the enthalpy change which occurs when 1 mole of an ionic compound dissociates into its ions in gaseous state. For example, this sodium chloride is an ionic compound in solid state. When this is dissociated into its constituent ions in the gaseous state, then whatever the change in heat is taking place, that is known as lattice enthalpy, and in this case this is 788 kilojoule per mole. Okay. Since it is impossible to determine lattice enthalpies directly by experiment, we use an indirect method where we construct an enthalpy diagram, and that is called Born-Haber cycle. Clear? With the help of Born-Haber cycle, we can determine the lattice enthalpy. Take one example. Born-Haber cycle for sodium chloride. The formation of sodium chloride in solid state can be represented by this reaction, that is overall reaction. Na solid, when react with the half Cl2, this will convert into NaCl, and in this reaction NaCl is formed from its constituent elements. That's why whatever the enthalpy change is taking place, this is known as standard enthalpy of formation. Okay. And this formation of NaCl can be considered that it may take place in the number of steps. Just see, first of all, this sodium solid will convert into sodium gas, and in this case whatever the heat we are supplying, that is known as the standard enthalpy of sublimation. When this Na gas will lose one electron and convert into Na plus gaseous ion, whatever the change in enthalpy, that is known as ionization enthalpy. Clear? Now this Cl2, this will dissociate, and for this dissociation we will give the bond enthalpy. Okay, and why we are taking this half? Because in Cl2 two atoms are there, but we require only the one atom. That's why we are doing it half. Okay, we will get this is Cl gaseous atom. Now this Cl will convert into Cl minus, and in this whatever the change is taking place when electron is added, that is known as electron gain enthalpy. Okay, and when this Na plus gaseous ion and Cl minus gaseous ion held together by the electrostatic force of attraction, then these will convert into NaCl solid. And in this case, whatever the change in enthalpy is taking place, this is the negative of lattice enthalpy. Why this is the negative of lattice enthalpy? Because as per the definition, lattice enthalpy is the change in enthalpy when 1 mole of solid ionic compound dissociate into its constituent gaseous ions. Okay, that's why we can say this is a one circle, this is a one cycle, and that cycle is known as Born-Haber cycle. The importance of the cycle is that the sum of the enthalpy changes around a cycle is 0. Okay, and if we apply the Hess's law of constant heat summation like this, that is standard enthalpy of formation is the equal to sum of enthalpy changes of different steps. Okay, that is this is the sum of sublimation enthalpy, ionization enthalpy, half of bond enthalpy, electron gain enthalpy, and negative of lattice enthalpy. If we put the values of these different enthalpies which are given here, okay, sublimation enthalpy is 108.4 kilojoule per mole, ionization enthalpy for sodium, that is 496 kilojoule per mole, bond enthalpy for Cl2, that is half of that bond enthalpy, 121 kilojoule per mole, electron gain enthalpy, this is minus 348.6 kilojoule per mole, and this enthalpy of standard enthalpy of formation of NaCl from its constituent elements in the reference state is minus 411.2 kilojoule per mole. Put all these values, okay, and then we can find out this lattice enthalpy, and this will be equal to 788 kilojoule. That's why we can say for this NaCl solid, when decompose or dissociate into Na plus gas plus Cl minus gas, this is for 1 mole, okay, then this is the lattice enthalpy 788 kilojoule, okay. Now come to enthalpy of solution. This is represented like this, okay. Enthalpy of solution of a substance is the enthalpy change when 1 mole of it dissolves in a specified amount of solvent, okay. If we change the amount of solvent, this enthalpy will also change. The enthalpy of solution at infinite dilution is the enthalpy change observed on dissolving the substance in an infinite amount of solvent when the interactions between the ions or solute molecules are negligible. Actually, what is the meaning of this infinite amount of solvent? Actually, this is the condition where interactions between the ions are negligible when we add the solvent. That condition is known as where we have to add that infinite amount of solvent, and at that time whatever the change in enthalpy is taking place, that is known as enthalpy of solution at infinite dilution, okay. This can be represented like this. This is one solid compound. When this is dissolved, then whatever the change, that is enthalpy of solution, and this will dissociate to give these ions. And actually this enthalpy of solution is sum of two enthalpies. One is called lattice enthalpy and another one is called hydration enthalpy. As we already discussed, lattice enthalpy is the change in enthalpy when 1 mole of solid ionic compound dissociate into its constituent gaseous atoms. And when these gaseous ions are hydrated, then whatever the change in enthalpy taking place, that is known as hydration enthalpy. According to Hess's law of constant heat summation, we can write enthalpy of solution is equal to lattice enthalpy plus hydration enthalpy, okay. Again remember, all these are in the standard state. For most of the ionic compounds, enthalpy of solution is positive. Now what is the meaning of this positive enthalpy of solution? That is, dissolution process is endothermic, clear? Therefore, the solubility of most salts in water increases with the rise of temperature. If the lattice enthalpy is very high, the dissolution of the compound may not take place at all. Clear? Dear student, at this place we must be able to find out that a given ionic compound is soluble in water or not. Okay, solubility of ionic compound depends on the relative values of lattice enthalpy and hydration enthalpy. If lattice enthalpy is more, it will not soluble. If hydration enthalpy is more, it is soluble. Is it clear? Now, enthalpy of dilution. It is the heat change when additional solvent is added to the solution. We already discussed about the enthalpy of solution. Once a solution is made in a given amount of solvent, then we add some more amount of solvent, then whatever the change in heat is taking place, that is known as enthalpy of dilution. The enthalpy of dilution of a solution is dependent on the original concentration of the solution and the amount of solvent added. Let us consider one example. Enthalpy change for dissolving 1 mole of gaseous hydrogen chloride in 10 ml of water is represented like this. For the sake of convenience, 10 mole of water is represented as 10 AQ. Okay, this is HCl gas, 10 AQ, and this is dissolved, and this is the change in enthalpy, and this is called enthalpy of solution. Okay, now let us consider the different set for this. Okay, in case of set 1, when HCl gas is dissolved in the 25 AQ, it means 25 mole of water, then this is the enthalpy of solution. Set 2, when HCl gas is dissolved in the 40Q, then this is the change in enthalpy. In the S3, set 3, when this HCl gas is dissolved in the infinite amount of solvent, simply we can say that is when interactions are negligible. Okay, then this is referred as a enthalpy of solution at infinite dilution. Okay, now if you compare these values along with this amount of solvent added, then we can say the values of enthalpy of solution depend on amount of solvent. Clear? Enthalpy of solution approaches a limiting value, that is the value in infinitely dilute solutions, which is represented by set 3, that is S3. Okay, now we will compare the set 1 and set 2. Okay, just see, in set 1 the enthalpy of solution is minus 72.03 kilojoule per mole, and in the set 2 the enthalpy of solution is minus 72.79 kilojoule per mole. Now subtract equation S1 from the equation S2. Okay, then we obtain this one, that is this equation, that this is for S1, this is subtracted from this one. Okay, then we will get this HCl 0.25 AQ plus 15 AQ, and this will convert into HCl 0.40 AQ. Now this represents that we have diluted this solution. Okay, in the original solution 25 mole of water is present, and we added more amount of water, that is 15 mole of water we added. That's why we have diluted the solution. And if we find out the change in enthalpy in this process, this will be equal to this one, minus 0.76 kilojoule per mole. And this value of delta H is enthalpy of dilution. Okay. And this is the heat withdrawn from the surroundings when additional solvent is added to the solution. I think this concept of enthalpy of dilution is clear to you. Okay. Thank you. Subscribe my channel to get the new videos from this chapter.